So today we're doing continuation of yesterday, horizontal projectile motion problems. So it looks a little bit different than yesterday's, but it is going to have, all right, basically the same concepts, the same ideas here. You have your x equations, your horizontal motion, all right? How far from the base is your delta x, all right? How far from the base, total distance traveled, how far away, that is x, all right? That's displacement. Vx is your horizontal speed or velocity, and I wrote in here, Vx is constant. There's no acceleration in the x direction. And time. Okay, now, if you're not given time, see how I put this in a little star here? If you're not given time, you're usually given height, which is dy, d sub y. If that's the case, you will use this equation to solve for time. 2 times the height divided by 10, square root. So, in this box, usually in these problems, you'll need to find time first. Then, you're going to go to either the horizontal or vertical equations to solve for a missing something. Now, if you have both Vx and x, right? If you have horizontal velocity and displacement, you can solve for t using the triangle, covering up t, delta x over Vx. Now, if you're given height, again, use this equation. The vertical motion equations. Your vertical velocity, because we're only launching things horizontally, we're not giving it an initial velocity. You're just taking literally gravity times time. The value that we're using for gravity, -10 meters per second squared. And then our vertical displacement. This is basically going to wind up giving us a negative value because it's going to tell us how far below we wound up going. But if they ask you what was the height of something, right? So like an apple falls out of a tree, you solve for this vertical displacement, it's -15.3 meters. And they ask how high up was the apple. You can't then say -15.3 meters because you can't have a negative height. So you just drop the negative in that case. And then here to find time. So they may be like, okay, you have, for example, you know delta x. They ask you to solve for Vx, right? You need 2 of these 3. You're given one of them. They ask you to solve for the other. That means they have to give you the height of in some form or another in order to get t. And then you'd find what t is, put it in here. You have delta x and t. You can solve for the missing variable. This one, silly, easy. A stone is thrown horizontally off the top of a 572 meter high cliff. So they want to know how long does it take the stone to reach the bottom. So you're given height. You can then use this equation. dy is our height. Substitute the values in. 2 times 572 divided by 10. Square root of 114.4 comes out to be approximately 10.696 seconds or 10.7 seconds if you wanted to round. So in the next problem, it asks you guys to find how far a ball lands from a cliff if it has a horizontal speed of 26 meters per second and is in the air for 7.7 seconds. Okay, so I even put next to the problem, or in the problem, what everybody stands for. That way you're like, oh, thank you, Mr. Lombardo, because now I know what I'm solving for. That usually is the biggest problem. People are like, I don't know what the hell I'm looking to solve for, blah, 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 blah. Well, I don't feel like listening to all that nonsense. So, how far something lands from a cliff. And again, I wrote it in here. How far away? How far from the base? Total distance traveled. Those are key phrases to find, all right, delta x, displacement. So that's what we're looking for. So I wrote out, that is what the question mark is. We're given Vx of 26 meters per second, a time of 7.7 seconds. The equation I would use, if I cover up delta x in the triangle, it's Vx times time. So that's what I did here. Multiply the two values, and you would get a horizontal displacement d or delta x of 200.2 meters. .2 meters. Okay. Now, in the next problem, number 3, it says that we have a steel projectile, and it is shot horizontally at 24 meters per second. Horizontally, that is your x directions, and it's a velocity, so you have Vx. From the top of a 1,258 meter high tower, which is dy. How far, delta x, from the base does the tower, of the base of the tower, does this projectile hit the ground? And I wrote, need time first. Okay, so they want delta x. So delta x, the equation for that would be Vx times time. So I need those two things. I was given Vx. Let me see if was I given time. No, it says we need time first. So since we need to get time first and we're looking for delta x, we can't use this t from the triangle. You can't use t is equal to delta x over vx because we don't have this guy up top. So in that case, but we are given height. So in that instance, then what we're going to do is we are going to use this dude. So using t is equal to 2 times the vertical displacement over gravity, which we're just dropping the negative sign, you can find time. So you're going to have to do that first. And what the heck was dy? 1258. So 2 times 1258. And then we're going to divide that by 10. And that's, so we're going to have to do the square root of 251.6. And that gives us 15.861. So we're going to call it 15.86 seconds. So that's time. And again, we're solving for delta x. So that equation is this dude here. And we have Vx that was given to us in the beginning of the problem of 24 meters per second. And we just solved for time of 15.86 seconds. So now we just need to solve for that. Times 24, 380.64, and the unit is going to be meters. Now you don't have to write like all of this here in the beginning. I'm doing that for you guys, so that makes sense to y'all. So a lot of these problems are two steps. You basically going to have to be given, for the most part, enough information to get time, then use that into a different set of equations. So for example, in number 4, you got a person standing off a cliff and they throw a stone with a horizontal speed, Vx, of 15 meters per second. And it hits the ground 47 meters from the base of the cliff. How high is the cliff? And again, I wrote time first. Find time first. Okay. Am I given height? No, that's what I'm looking for. So I can't use this t equation. Can't do it. So if I scoot up here, I was given delta x and Vx. So I could use this t equation from the triangle. And if I cover t up, it tells me to use delta x divided by Vx. All right, so delta x was what, 47 meters, and Vx was equal to 15 meters per second. So we're going to do 47 divided by 15. And so t will equal 47 divided by 15, 3.13. So it's like 3.13 repeating, so we're just going to chop it there. Seconds. So I needed this first. And why did I need that? Well, because when solving for dy, when solving for the height, I need basically one thing, right? If there is no initial velocity in the y direction, I need time because g is constant, all right? It's either that negative 9.8 meters per second squared, but we are using 10. So we're going to do this number squared times negative 10 divided by 2, and boom, we have our answer. So I'm going to just highlight this, copy, Control C, go down here, skip the paps. I'm going to make this a little bit smaller. Can I do that? Cool. Okay. I mean, I don't really need to write it, hopefully, but I'm just going to do it for this. Negative 10 meters per second squared, and time we solve for from the part right above that of 3.13 seconds. So 1/2 times negative 10 times 3.13 squared. How do I do the squared thing again? Control period. Control period again to get out of that. All right, so then you're going to basically plug and chug this into a calculator. 3.13 squared times negative 10 divide by 2, and I'm leaving or left with to get the subscript again. That one's control comma.
I got 4.8.
What? You got 4.8?
Yeah.
Let me double check my math. 3.13 squared would be 9.7969, times it by -10, and then divide by 2. I got negative 48.98.
Yeah.
Okay, that's the displacement. dy is vertical displacement, but they asked how high is the cliff. So what does that mean? Height equals, just drop the negative. And you guys can highlight, your answer here and all the work, whatever. I'm just gonna do that for now. Okay, so number 5 is just like number 4. So let's go to something with something a little bit different. Let's go to 6. Okay. So in this problem, it tells us that we got a bridge that's so many meters high above a river. Okay, using a weighted lead fishing line thrown from the bridge, it has a horizontal velocity of 16 meters per second. They want to know what is the horizontal displacement? What is delta x? How far is it going to travel before it hits the water? So they want delta x, and that equation is here, covering up delta x, vx times time. So the best thing you guys can do is to always have your equation ready to go. Where's 6? All right. So this is what I definitely need to solve for first. Well, technically, this is what I'm. Whoa, buddy. This is what I'm asked to solve for. So if I know the equation, vx times time, I know basically what I have. So I like to do that. I have vx is equal to 16 meters per second. And t equals, don't have t. That's a problem. So, like I said, on the top of this guy, if that's the case, you're usually going to need time from one of the other spots. So since we can't use the t equation here because we don't have delta x, that's what we're looking for, you need to use this equation. 2 times the height divided by 10 square root. And are we given height? Yes, we're given our dy. So over here, let me scoot up. Got to use this equation. All right, so that is going to equal, what is the dy here? 176.4. Oops. All right, so 2 times 176.4 divided by 10. That's 35.28, so we're going to have to take the square root of that number. .9396, so if we round to 2 decimals, we're looking at 5.94 seconds. So now that you have time here, this value goes right to this 5.94 seconds. And now you have everything you need to solve. 16 times this 5.94. And I'm left with 90.24. And that will be in meters. So this is like the final answer. This is what the actual problem needed. But you needed to do this first. So again, these guys, they want to know the height. You need time. So time, I wrote here, time first. You have Vx and dx, or you have Vx and delta x. You can solve for time, get time, plug it in to the dy equation, and then solve. And then this one's the 7 is the same as 6. And 8 is the only one that we hadn't quite looked at, but they just ask you, okay, if an object rolls off the table and it's in air for 4.95 seconds, what is the Vy when it hits the ground? So Vy equation is up here. Because our initial velocity is 0, we're just going to get rid of that whole John Cena there. So it's just going to be gravity times time. Gravity times time. So you're going to maybe just take this equation, copy it, slap it down here. Again, G is a constant. For us, we're using the negative 10 meters per second squared. And time they gave us as 4.95 seconds. So Vy is going to equal, what is that, negative 49.5 meters per second. Now this one you keep negative because the negative is indicating that it's on the downward, all right, it's moving downward. Guys, anyone have any questions? Anyone on the meet? Anyone in class? You guys have questions on how to go about this?
No, I'm okay.
All right. So guys, when we have our test on Tuesday, you're going to have to think about 4 or 5 problems dealing with like this set of equations.
Well, like creating a problem? Solving
Solving for the problem. So you'll be given a problem. They're going to be very similar to these on this worksheet. All right. So these problems, and a lot of the times you're going to need to find time first. So if you're given both Vx and delta x, you can solve for time that way and then plug it in over here. Pretty much get time and then you solve for either delta x or Vx. Get time and then either solve for dy or Vy. That's basically it. So there's like 2 steps to most of these problems. But some, like the first one, it was just 1 step. They give you a height, find time. Okay. All right.